not get this in first year calculus, you really don't understand everything about calculus or how it can be used. Really, you just think of it as rate of change, that kind of stuff. Okay? But let's start off by saying that integrals can be used to find the area between regions that happen to be between two graphs, two functions. That means we can find the area of things that are not linear sides. Because that's stoichiometry. We can do that. So we can find weird shapes, the area of weird shapes. And so let's consider this. We have a region that lies between two curves, let's say f of x and g of x, and between two vertical lines for right now. X equals a and b, so you know a lower bound and an upper bound. And we want to make sure they're continuous, at least between a and b, so that we really have sides there, okay? Then, here's what we've got. Something that kind of looks like that, okay? So we've got one function, another function, we've got some area in between, and it's bounded. So we're looking for the area of this weird looking shape. Well, one thing we can do is we can divide that region into a bunch of strips of equal width, each with the same width base, so the change of x would be the same. And then we could figure out all of these so-called rectangles in here and add them up, and that might approximate that area. I don't necessarily want to approximate the area, I really want to know the area. Because to get the exact area, I'm going to have to let the number of rectangles approach infinity. Now I really don't have that time. Plus, I know we've been working with integrals, and integrals, doesn't it give me the area under a curve to the x-axis? Okay, so think about this. Why don't I just do this? The area, can I not get them both? Just a bit. There we go. There we go. I don't have to do rectangles. We're so past that, doing rectangles. We want the exact, okay? So why don't I take, I'm interested in the area between a and b, so the integral between a and b. That makes sense. The integral of f of x, why f of x? Because that's the one on top. But notice that's going to give me the area all the way under down to the x-axis. I don't want that area. I just want the area all the way down to the next function, g of x. Okay, so I don't want this area. That's exactly the area that's under the other function, g of x, down to the x-axis. So if I take the area of the whole thing of f of x and subtract the area under the lower one, I should get the area for the whole thing, right? So take the whole thing minus the part I don't want. I should be left with the part I do want. Makes sense to me. Bingo. There's your area. Okay. Also, this is cool, guys. Unlike the area under the curve that we looked at previously, I guess I can make this bigger. Where I knew it was giving me net area because some of it might be under the x-axis. I don't care if it's between two curves because it's always going to give me total area. It's always going to be positive. I only have to worry about part of it being negative and maybe adding it back if I'm under one curve. If I'm looking for the area between, it's always going to give me a positive area, which is going to be total area. That is good. Okay? So that is going to be how you find the area between two curves. That's it. Now I suggest it's always helpful to sketch the region so you can figure out which is the top curve. Because you want to do the top one minus the bottom. So, should I put it back on the area formula between two curves, which will always be positive? Hey, we're not gonna add up all the rectangles. We're not gonna do that. We're gonna do this. And it's always gonna give me a positive area. I don't have to add anything back. If they ask me, hey, what's the area in between? You're gonna get the area in between. You're not gonna get part of the area in between. Okay, and then I would say always sketch. Rough sketch, just so you could tell which one's on top. Doesn't have to be perfect. That's what I kinda like about this stuff. Although we'll start off with some perfect ones. If we shall. Oh, and then I want to mention this. What if those two curves at some place, the one that was on the bottom becomes the one on the top? They cross. Well, that's easy. Find where they intersect, set the equations equal to each other, and you can solve for x. Oh, because it's always, I'm inputting x values. So find the x value where they intersect, and then the other one becomes on top. So you might have to add 2 or 3 pieces of area to get the total area. Okay. Let's do some, right? So let's look at number 1 here. Let me get down there. Find the area of the region bounded by, this is how they often look, y equals e to the x, bounded below by y equals x. So we're starting kind of, it's telling you which one's on top, which one's below. They won't always do that. It'll say find the area between these curves. Bounded on the sides by x equals 0 and x equals 1. So I've got that up here. So here's y equals e to the x. Here's y equals x. And bounded between 0 and 1. What I've got in that figure right there is just an approximating rectangle. If for some reason you wanted to do rectangles, I don't know why. I don't even think on the AP they will have you estimate with rectangles. That's just one time with Riemann sums at the very beginning. That's it. We're looking for that area, right? Wait, did I get mine? I have the actual answers. Let me pull out my handy dandy notes here. So I can make sure we get the right answers. Oops. So what I want to do is I want to do the integral. Good Lord. Brand new pen here. Area, which I know is going to be total area, is the integral from, let's see, 0 to 1 of the upper minus lower. I'll even put that up here. Upper minus lower. So that's going to be the integral from 0 to 1. The upper one must be e to the x. Minus the lower one must be x dx. get the dx. So basically, that's the integral from 0 to 1 of this one, dx. That'll get me all the way down to the x-axis, minus this one, which represents the part I don't want. All right, so let's see, what's the integral of e to the x? E to the x. So I got e to the x for the first one, and I'm gonna take that from 0 to 1, minus, what's the integral of x?
X squared over 2.
X squared over 2. I'm gonna take that from 0. So let's see, that will give me e to the x, that's e to the 1, minus e to the 0. Right? Minus 1 squared over 2, minus 0 squared over 2. So let's see what I got. E to the 1 is just e, right? Minus e to the 0, anything to the 0 power is just 1. Let's see, minus 1/2, minus 0. So it looks like I've got e minus 1 minus 1/2 minus 3/2. There's the area. They didn't give me any units, so I don't have to say square meters or something. If you say square units, that's fine. Questions? Anybody think that's cool? Right now, you are the only 5 people in this school that know how to find the area between 2 functions. That's it. This whole school. 1,000 meters. Can I erase it? Do you have it? Okay. Shall we look at another?
Yes.
And leaving the e in there or leaving the natural log, that's always a more exact answer than putting it in a decimal equivalent, unless they ask you to. So here's the next one. Again, I've provided the functions. Find the area of the region enclosed by the parabola of y equals x squared and y equals 2x minus x squared. It doesn't say which one's above and which one's below. This is how the questions often look. Just find the area between these two. And you're probably gonna go, between what x value and what x value? Between where and where? You want me to find it forever? There's no area in finding it forever. That must mean they intersect, because they didn't give me any x values. So what we do is we graph the parabolas. I want to see which one's on top. Well, obviously that's the parabola pointed up because it's positive, and this will be minus x squared plus 2x. Obviously that's going to be going down.
Okay.
So here's the y equals x squared on there. Here's the y equals negative x squared. There's the parabola going down. And then we want to find it says the area enclosed by those 2 parabolas. I think there's only one region to worry about, because these are just going to keep going forever down, and these are going to keep The only place where they're gonna intersect is overlap is right here. That's what I'm looking for. So I'm trying to figure out which one's on top, which one's on bottom. So area will be the integral. The one on top seems to be that one. So that's gonna be minus x squared plus 2x. Minus the one on the bottom, which seems to be this one, x squared. In terms of x. Now I need to figure out from where to where is this happening.
0 to 1. Yeah.
So you can set them equal to 0. Set that one equal to 0. We could probably solve that one by hand. Where does x squared equal negative x squared plus 2x? And so, let's see, that's gonna be 2x squared plus minus 2x equals 0. If I got them on the same side. Let's see, I can factor out 2x. That's gonna be x minus 1. That's gonna be x equals 1 or 0. 1 and 0. X equals 0 and 1. So 0 and 1. Oh, now I got my interval of integration between 0 and 1. So let's just integrate here. We can break them apart, or keep them all together, do them one at a time. That's the key. Let's see, negative x squared is going to be negative x to the third over 3. And this one's going to be x squared over 2 with a 2 alpha on, so just x squared. And this one's gonna be minus x cubed over 3. And I wanna take that from 0 to 1.
Well, why did you not just, like, for example, put the x squares together and take the 2 out?
Yeah. Why don't we do that?
It's going to be much faster.
Yeah. So I've got minus 2 of these, right? X cubes over 3.
No, I see before doing that, like in the first step. In the first step, you can, yeah.
Put
No,
these
that one.
together
Yeah, then
already.
take the 2 out.
That's true. That's true. Let me put that over here, what you're saying.
Like, I think it's going to be faster.
0 to 1. We've got the minus 2x squareds here. Plus the 2x here.
And the 2
Yeah.
goes out.
Yeah, and then you can pull out the 2. Yeah, you're probably right. Want me to do it that way? We can do it that way. Yeah. Thank you. We'll pull the 2 out.
Yeah.
You want to pull the minus 2 out?
I mean, I did on the 2.
Okay. I'll pull that out. And then I've got x squared here, and I got minus x. If I pull the minus out. So now I've got the minus 2 out here. What I've got left over, I'll take the integral out. So that's x cubed over 3. And then that's going to be minus x squared over 2. Taking that from 0 to 1. Does that look right? Yeah. That is faster. Combining like terms before we even take the integral. Yeah. And then pulling out any constants. Sure, why not? Okay. So now I've got negative 2 out here. Let's plug in the 1. 1 cubed over 3 minus 1 squared over 2 minus plugging in the next one, which is 0. 0 minus 0. Oh, I'll guarantee you some of the free responses will be this, where you're plugging in ones and zeros. Probably without the calculator. I should have done this. Okay, so that's -2 on to 1/3 minus 1/2. Is that 2 minus 3/6? Which will equal 2 onto 1, -1/6, right? Wait. How are we ending up with things? We should not be ending up with a negative. What did we do incorrectly? Minus n squared.
I think so.
2 be negative?
Yeah, you forgot to make the 2 negative.
Because it was negative there and then. 'Cause
Oh,
one-
yeah, you're right,
'cause
you're right,
one
you're right.
negative two
Negative,
times
negative, I
negative
forgot the
1/6.
negative. You're exactly right.
1/3.
Always comes down to arithmetic, doesn't it? And usually it's that negative sign. So that's gonna be positive 2/6, which is 1.
1/3.
Thank you for finding my error. But after just telling you it's always gonna be positive, getting a negative is like, what the heck did I do? I lost my negatives. You know what I think? I think that's a good place to stop for today. It's been introduced, maybe you can try it.